Okay, when it comes to circuits and physics, there are three important variables that you need to know for your main equation. One is V, which equals voltage. The second one is I, which funny enough is current. And the third one is R, which is equal to resistance. So what resistance is the amount of resistance the wire or a metal has when electrons are passing through it. So when you plug a wire into electric circuit, into a battery, when that electricity travels through that wire, it encounters resistance from the particles in the metal of the wire, and then it heats up. So that's why when you're vaping, you press a button and then it heats up that coil, or like a toaster. When you press in a toaster, the electricity passing through those wires in the side of the toaster heat them up because they have resistance. So if you rub your hands together like that, you create heat. The same thing happens with wires. When electricity passes through it, it creates heat. It's the resistance, it's the friction of electricity passing through the metal. So an important relationship between these three things is V, voltage. So I'm going to write it down first, if I can spell. Voltage equals current multiplied by the resistance of a circuit. Okay? So this is abbreviated usually by V equals IR, I times R. So voltage is current times resistance. So a lot of times in problems, they'll provide you with the voltage, and they'll provide you with the current. They'll say, I don't know, you have 24 volts, and the current is 12 amperes, or amps. That's the voltage. Volts are, okay, I spelled that wrong. Volts are the unit for voltage, as you can probably tell from voltage, and amps are the unit for current. So they usually provide these two things, but what's the tricky part is finding how much resistance in a circuit. So there's two types of circuits. The first one, and the easiest in my opinion, are series circuits. Series circuits. Okay, so I'm going to draw this out. So how they represent a battery or source of power is this by this. They do like a big line and they like draw out the rest of it. And this is how they show a wire or resistance. So let's say this is a 12-volt battery. Okay, so let's say they will provide you how many ohms. Ohms is this symbol. It's the Lululemon symbol. I thought you probably recognize that. It's the Greek symbol omega, and that's units. So it'll be like 5 ohms. That's a unit. This is the ohm symbol. That's a unit for resistance, which is this. So here they'll usually provide you, or actually they will always, in your case, provide you with the resistance of each individual system in the circuit. So let's say this is 2 ohms, this is 4 ohms, and this is 3 ohms. So what most likely they'll ask you is to find the resistance in a circuit. For this, they'll provide you this. They'll say find the total resistance, which is R tot, or RE, with a little subscript E. You see it said differently, written differently, but it's one of those two things, and they'll ask that. And how you find that, so you have to remember, in this type of circuits, they're all lined up. They're all in one straight line. You could draw a line through them. There could be one here, though, and it's still, you could draw a line, like it follows a path. So they're series. So one after the other, like seasons of a TV show, like series. Just try to remember that when they're all in a line. The way you do that, the way you calculate the total resistance of a series circuit when they're all in one line, is super easy. You can do it in your head. You add them. So if you have 2 ohms here, 4 ohms here, and 3 ohms here, that's going to be 9 ohms. So the way you calculate that is the 2 from that one, plus the 4 from that one, plus the 3 from that one. And that's going to be equal to 7 plus 2 is 9. 9 ohms. So that's simple enough. That seems simple. So then they'll probably get the next, if that was the A of the problem, the B will be, now tell me how many amps is in each resistance thing. So in a case, So first of all, you do this. You'd find out how many amps are in the total thing. You'd say, if you have the V equals IR, and you're trying to solve for I, which is the amount of amps, you'd solve for that by dividing both sides by R. So you divide this side by R, these R's cancel, and you divide this side by R. So then you're left with the amps, which the current, which is what you're trying to find, equals voltage over resistance. So and that's the total resistance. So you found the total resistance up here, right here. You found it to be 9 ohms. That's why they'd probably ask you that first. And then you know the voltage because it's given. If there's only one battery at 12 volts, then the total voltage is 12. So then that equals 12 volts over the 9 ohms. And that's going to equal 9, 12 divided by 3, 4, over 4/3 amps. That's a funky number, but I'm sorry for that, but it usually would be a whole number. It'll be something like 2 amps or maybe even bigger than that, like 12 amps or something. Let's just call it 2 amps to make it easier for the next stage of the problem. 2 amps. So basically, if you found the total current in this circuit is 2 amps, it might ask you how much current is it in each resistor. That's what they call these little things, resistors. Just imagine they're springs. They're little springs that heat up, like little coils in a toaster. So basically, what you do is you add up the total amount. So let's say there's 2 amps. 2 amps in the whole circuit. You add up the total amount of resistance, which is 9, and you divide that. So 2 amps divided by 9 ohms. Then you realize this 2/9 is 1. It's going to be, I don't really want to do that math, but it's 2/9 amps per ohm. So per each ohm, because you just did that, do 2 amps per, there's 9 ohms total and 2 amps total of current. You have 2/9 amps per ohm. So let's say if they ask you how many amps are going through this resistor, you say since there's 2 ohms here, you know there's 2/9 per ohms. You just do 2/9 times 2. It's going to be 4/9. 4/9, and that's be your answer. If they ask you how much is in this resistor, you say 4 ohms, and you know there's 2/9 per ohm. So 2/9 times 4, well, that's just going to be 8/9, and so on. If you do it with the 3, and then that'll add up to 2 eventually. If you did it for all of them, they all add up to 2. It's just proportioned for how many ohms each. So this is per ohm, and you just proportion it. So 2 times 2/9, 4 times 2/9, and 3 times 2/9, respectively. Okay, so the next type of circuit is a little more tricky. I know this seems complicated already, but bear with me. It's not too bad once you get used to it. Okay, so the next type is parallel circuits. I'll remove this now. That's not the right letter. So for parallel circuits, this still applies. Voltage equals current times resistance. That's always going to be a factor. You can always use that equation no matter what. But the way you find resistance is different. So for what a parallel circuit looks like is this. So we have our battery, and we have a resistor here. Then we have another resistor. Let's just start with 2 for now. So we have 2 resistors here. Let's say each of these is 2 ohms. Make it easier. 2 ohms each. Okay, so in a series, you would have just added them. But since they're parallel to each other, you can draw a line across them, through them, not this way. So normally you'd have, let's just try series 1 next to it, how it would look. See how they're in a line? You could draw a line through them this way, and that means they're series, and you could just add them like I just taught you. So, but that's not what we're dealing with now. This is different. You have to recognize when you're given a picture like this that there are 2 that they're across from each other, and they are not, in fact, a series. They are parallel, as you can probably tell. Remember, it's parallel. They're parallel to each other. That's easy enough to remember. But the way you find the total resistance, because like you have to remember, this is total resistance. This isn't just one of them. You can't just add these or like look at one and put that in there. This is total resistance. The way you find total resistance is by using this equation. 1 over total resistance is equal to 1 over resistance 1 of the first resistor plus 1 over the resistance of the second resistor. So these are both 2. So what's 1 over, let's do this right, rewrite this. what is 1 over the first resistor? The first resistor is 2. So 1 over 2, that's easy enough. That's 1/2. The second resistor happens to be 2 in this case as well. So we do 1 over 2. So what's 1/2? What's 1/2? I think that should be easy enough for you. That is 1. That's easy for anyone. I realize that sounded condescending. I didn't mean that condescending. I'm just talking like I'm a teacher. Anyway, it's 1, so that's going to be 1. But so 1. So in this case, this is not the answer. You have to remember that. This is 1 over that. So 1 over this is the answer. Because you have to remember there's this. So then you get 1 over R total is equal to 1. In this case, it's going to be the same, because 1 over 1 is 1. But let's add a third. Let's add a third resistor. So then we have 1 over R total. So anytime you count the number of parallel resistors and just make the equation suit it. So 1 over R1 plus 1 over R2 plus 1 over R3. So before you start this with a parallel circuit, I want you to count how many resistors there are in a line. 1, 2, 3. If there's 3, then you need to do this 3 times. If there's a fourth one, you'd add a fourth one. Just dot, 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 etc. until you get to how many resistors there are. So let's do this with 3. They're all 2. Oops. 1 over resistance total is equal to 1/2, because it's 1 over 2, plus another 1 over 2, plus a third 1 over 2. So this is going to equal to 1 plus 1 plus 1, 3 over 2. So that's the total resistance, it might seem, but that's not. You have to remember that that's equal to, this number is equal to 1 over the total resistance. So rewrite it, 1 over the total resistance is equal to 3 over 2. So if you flip this, then it's equal to 2/3. And that is the total resistance. And that's what you substitute in this equation. So let's say this battery is 12 volts. Then you do 12 volts, and you're trying to find the current again. You do the same thing as last time, and you'd get that current equals voltage over resistance. You can memorize that if you want, or you could just get that by dividing both sides by R. So then you do this equals 12 volts divided by the number you just found here, which is the total resistance. So that's 2/3. So 12 divided by 2/3 is the same thing as 12 times 3 over 2, because you flipped the reciprocal. And that's equal to 36 over 2, which is equal to 18. My bad, that took way too long. 18. So that's the answer. That's how many amps. Simple as that. If you have any questions, just ask me.